Bismillah ar-Rahman ar-Rahim. Assalamu alaikum and hello everybody. This is our next meeting on the research group of machine learning. Over to Dr. Raza.
Okay, thank you very much, Dr. Salaha. So, what I am going to discuss first, we had an issue, and or we can say sometimes bugs from the previous session that sometimes the TS model wasn't work. So I'm going to start from there. Uh, so so we had some data set in R in for rainfall data set. So let me go there. So that I have stored the data set in actually in my uh, file somewhere, and let me show you for Mr. Jawad also the data set. So here is the data, Iran rainfall, and now I actually created an automatic function so that we will do easily the job. Hopefully today most of the job will be done and be ready for the paper. So here is the data set, rainfall. So we had year, we had January, February, March, April. We had the country, Iran, and this is the code for the country. So we had similar data for Pakistan, for Kenya, for other countries. So the object is that to make some prediction model.
Dr.
Uh,
Raza, sorry to interrupt you. Could you please bring the mic closer to you?
okay, okay. Is that okay now?
Now it's better.
Okay, okay. Thank you. Yeah. So the
Thank you.
objective was to build some prediction model so that we can predict what will be going on in the next years, and also we want to see the effect of the time as the time passed. Is the rainfall is increasing or decreasing, and by which rate? So this too was the question, and we want to also implement both traditional statistical models and machine learning models to see which one have better accuracy or better performance. So the first things we need to do is to make a time series model. What is the time series? In fact, in time series, so I think you all may know, so we have a time and then we have observation of any value at time. So here we have year as a time, and like this is a monthly in fact rainfall from January to September to December, and then we have the rainfall. So obviously this is a time series model, and we want to see just based on these factors can we predict time in fact the rainfall for the next few years or not. So of course, there might be some other predictors like industries, economic, like the carbon dioxide, and so on. So in this way, actually, we are developing a paper with Dr. Ahmad and Dr. Abdul Khadir at the University of Windsor to looking at the time series GLM models. Means that we have both time series like this and some other predictors, because here we don't see the effect of other variables in the time, actually in the rainfall. So but this is the first action that we are going to do to see, just by looking at the trend of this rainfalls, can we do prediction for the
Dr. Raza, I'm interrupting you. I think Mr. Jawad will listen to the recording and he will catch up with things. But you can proceed further from where we stopped last
Okay,
time.
sure, sure. Okay, so the first things we do is just making a time series. So how can we make a time series? So first I read the data. So just by simply this code read CSV. So because the data was a CSV file, and this is the past that I have actually stored my data. So the data name was Iran rainfall from 1901 to 2020. So now I read uh, this pass. If I look at this data set, as I mentioned, it is So rainfall, year, statistics, country. So it doesn't look like this is a time series for R, so we have to make it as a time series. So I'm going to make a time series. So how can I make a time series? I can say like Iran, TS Iran equal to TSDF underscore Iran rainfall. And then I will make it like a monthly time series. So the problem from last sessions that Dr. Salha, if you remember, there was an issue here, start and end. So whenever we put a start, we should say which month, and whenever we put end, we should also say which month. So I had forgot this part in the previous session. That's why the model wasn't working very well. So here we put like TS Iran. So this one, this variable. Oh, sorry. We have this variable, and then we want to start from 1901, first month, January, to December 2020, and it should be frequency equal to 12 because this is monthly. If that was quarterly, then the frequency should be 4, and so on. So we make the time series, and if we look at the TS plot, then it will looks like something like this. Okay, so we didn't like this one so much, and in fact, we are interested to see the last maybe 20 years, so we can make it like for the last 20 years and to see how much is the pattern. But for now, that is just a simple task, so we don't go there. If we want to do that, so we can put just, for example, 2000 to 2020, and we can make just this one. So, and here is the output from 2000 to 2020, right? What also other, in fact, plot is so important. We want to see how much is the trend. We want to, in fact, to decompose this time series model into different ways. So let me do first this decomposite TS plot, and then you will see what's going on here. That is so interesting plot. So this plot is interesting because it will show us both all the trends, all the seasonality observed. So this is the observed one. This is the trend. This is the seasonal effect. So, and this is the random part, right? So what information?
Dr. Raza, this was the last thing we did last time.
Uh, we haven't done this one, in
No,
fact, last time.
no,
No,
this,
we
Okay.
didn't do this one. Yeah.
yes,
Right.
this is amazing. Decompose function is amazing. This is
Yeah,
interesting.
it's
Very interesting.
Dr.
Go
Raza,
ahead.
Dr. Raza, you did say to us that you wanted to improve the code. So during this last week, I think you must have done more work. And this, what we are seeing now, is that the result of that further work that you have done?
yes, I will show you. I actually I have the result. If I just click here, you will see my final results. So let me firstly
Okay.
show maybe the results. You will be convinced. Then I will go back to okay. So
Yeah.
here is the
Okay.
results: MAE, RSS, MSE, and the models. Okay. So we have
Just follow the
results.
story. Yeah. Just go ahead and follow the story. Yeah.
Oh, okay. So Dr. Salah, we have the results here and almost ready. So for Iran and
I'm
same.
just saying to you that you had said to us that you needed to further improve the code. So I'm sure you must have done that during this past 10 days.
Yeah,
So
yeah,
that's
yeah. Thank
so
you.
so
Yes,
what
I
you're
have.
showing us, what you're showing is us now. I'm saying that it is the result of that even further improved code. Is that right?
Yeah, yeah, yeah. Even like I almost finalized, So
Okay, that's what I'm saying. That it's great that you have done all that work, and now you're saying to us that it's almost finalized. It's highly commendable that you did this. Thank you so much.
thank you very much. Yeah, so I the goal. So let me like explain what was the goal to everybody one more time. So the goal was to actually to write a paper, right? So final goal was to write a paper, and
Right.
for the paper, what I showed from the last session is that we need to have some models. We need to look at to see which model is better in terms of prediction accuracy. So for prediction accuracy, we use sum of square errors, and sum of square errors is good, but if there is an outlier, then it will not be good measurement. So that's why we
Right.
can use like mean absolute difference and so on. So, and I have proposed a bunch of model like several models here, and I wrote the functions and everything, and then the models like have been compared here, and we see the comparison of all models. So this is the things that
Right.
we wanted, in fact, to catch this one and make it ready for the paper. So
Right.
the result is almost done here. Just what I'm explaining is just one more time for our brain that where we wanted to start and where we wanted to go. So
Right.
the first things that I mentioned we need to actually to check is to look at this part was error, right? If you remember, we had an issue from start to end, and 1 month in fact had
Yes.
a problem.
Yes. Yes. We had an
So
issue.
Yes,
yeah,
I
so
also
the
saw
way
one
that
extra month.
yeah,
One
yeah,
extra month.
exactly. Yeah, exactly. So the way we should do this one, we should start from months, which months we start and which months we end it. So we need to actually to implement this. Also, the composite function is so interesting because it will show us how much is the terrain, how is the terrain, and especially for the last 20 years or maybe 30 years, this is interesting to see how the trends
And
in
this, it's very, very interesting. And the seasonal pattern is so, I mean, it's just almost the same thing going on. Like,
exactly, yeah.
it's so regular. The seasonal pattern is very regular. Mr. Harris, I would like to encourage you to also give your input because you have also done these kinds of things.
Yeah, I have seen this very excellent work, Dr. Raza. So I'm just inspired to see that.
Thank you very much. So thank you, Dr. Harris. So I call you Dr. Harris because I believe you are getting PhD. So,
Thank you.
but the thing is that what we see here is that so mostly when we look at the terrains, we expect that the terrains should be somehow, a linear model, which in fact is not so much obvious from here. So that one thing that we expect that the traditional statistical models may not be so much appropriate for this data. So this is the first things that we see from the trends.
But Dr. Raza, because I only know the ABC of time series. So for me, this I would just simply draw a straight line at the ABC level, and I would say that it is almost well, it is not exactly horizontal, but a little bit up. It's going upward very slightly. So all that which I'm saying is you think is not appropriate.
Yeah, if we see the fluctuations, right? So here is if we look at like this line, if we see the fluctuations, specifically in somewhere there are so much fluctuation to the top, So
Yeah.
and here is there is a big issue here. And
Yes.
also looking at this function like random function, so we see that somehow the variance is getting so much large, like in this area, right? So maybe like one appropriate model could be like the Garch models. Maybe Dr. Harris, I wonder you have worked with them or not, but in this case, whenever we see like a high volatility, which may happen, we may go through also implement some Garch models. So we don't say that using linear regression, linear analysis is not correct. But we see like somehow, you know, like especially in these areas, like these areas, there are kind of, you know, fluctuation, bad fluctuation that like it's, you know, it's in fact
Okay.
violate
So could
the
you remind
linearity.
could you remind us one more time exactly what I mean, because some of us don't know it. What is Gauge model?
So Gauge model is so whenever we don't have a constant variance,
Yes.
in fact in our time series model, so both ARIMA, SARIMA, and AR, so they in fact they needed the variance to be a constant model. So whenever the variance is increasing or decreasing during the time, I mean the variance itself is affected by the time,
Yes.
then
Yes.
we could also use Gauge models.
And what does GARCH stand for?
Oh, generalized. So let me,
Auto
yeah, let me,
regressive?
Gauge. Sorry,
Generalized autoregressive conditional
yeah, yeah,
heteroscedastic model.
conditional, heterocyclic
Condition.
model.
Yeah.
Gauge.
Okay. Heteroscedasticity. I get it.
Yeah.
Actually, these models are based on the conditional assumption of heteroscedasticity. So if our data set are suffering from the problem of heteroscedasticity, then we will move toward the arch or Gauge model.
Actually, your mic, you need to get closer to your mic.
Sure, I'm telling
That's
that
better.
if our data
Thank
is
you.
having the problem of conditional heteroscedasticity, the error
Right.
term of the model is some kind of heteroscedasticity, have some kind of pattern, then we will move toward arch or Gauge model.
Okay, thanks a lot.
Yes, thank you, Dr. Harris. So, yeah, so this plot is, I think we will need this plot at least to show what was the trend within the 20 years, within the last 20 years. And one good thing is, in fact,
Sorry to interrupt you, Dr. Azza, I'm sorry. Like,
no problem.
actually, we have the data for 100 years or so. But what I have understood from your last session and from today, that you are using the last 20 years to have an idea about that, about, you know, the nature of that time series. And then once you have decided that which model is the best to use, then you will use that model for the entire 100 years.
No, Dr. Saleh, what I said is here, if we actually we have the picture of the last 20 years, then the picture looks nice, looks better than if I had like it for 100 years, because you know, we don't have that much space in the x-axis to show exactly the trends. So, but the way you explained that, it's, I think you are talking about training and testing. I will explain that one later. It's okay. But
Okay.
here, what I said is, what I told is, we need to look at like maybe looking at the last 20 years. You know, in this picture will be better. You know, will have better screen for us to see how is the trend in the last 20 years. And I found one interesting thing is that I will show you that. If we consider the last 20 years, then we will see that the drop of the rainfall is higher than if we consider the time series of 100 years. So let me go there and I will show you. So I changed my data to 1901 to use all of the in fact the years, and just one more time to have these things to see how they looks like, and then we go from there. So this is the trend
Yes.
for the last 100 years, and
So it is a stationary thing first, and then there is a change point where it starts declining.
yeah, also the variance, what we see here is that by this time, maybe this is around 1970 or 1960, we can say the variance was less than, you know, after this time, right?
Yes.
So So this is
So that's very, very interesting. I mean, what happened in 1970? So all this happened.
Yeah, maybe there is something related to industry, or I don't know, population of the world. And also the random error, the random term seems also here. See, the fluctuation or the variance is
Yes.
in fact increasing from this time, and that's
Yes.
why maybe after this time people started to see very extreme rainfalls or so on. So we see here this one is should be interesting to the paper to show what happens after maybe 1960,
Right.
around that one, that time.
So please do this for Kenya and for Nigeria and for Pakistan.
Okay,
So
sure. Let
so we
me.
can see what's happening.
Okay, sure. So okay, let me copy this. And just let me change EK, and let me look at what was the Pakistan. Yeah, this is here, Pakistan. So I read the data and then EK. I should use like a data, then it should be okay for every country. Like not like
Right.
this, but for now, let me just change it quickly, because at the end I will give a function to make everything.
Right.
PK. Okay, so yes, this is the pattern for Pakistan. It's different than from Iran. So
And this is for the last 20 years, right?
no, this is for 100 years.
Oh, okay. Okay.
Yeah, this is for 100 years, and
Even in this one, we can see that there's more variability, uh, you know, in the later part and less variability before. Yeah.
yeah. Somehow, yes, we see here fluctuations. Yeah. So the seasonality is obvious because it is rainfall, but the variability is in fact is high. So uh,
So in the paper, Dr. Raza, when we compare the situation of the four countries, so I mean, how do we compare?
but we could have this figure for each of them, or then maybe I have to go to I haven't actually done that one, but maybe if we want to go to compare all countries together, then maybe I have to go to use ggplot to have the terrains all together for 4 or 5 country or 6 country. But for now, just but if we go that, then we don't have the random. So maybe we will have this picture for all 4 or 5 countries separately.
And Haris, do you have a suggestion here from your experience?
Yeah, we can definitely get the data into two parts, and we can present them separately to show
Please, you have to get closer to the mic.
Yeah, please. We can convert data into two parts, and we can compare them directly by drawing them. And I thought that will be a better way to visualize them. What you say, Dr. Raza?
Yeah, I agree. We can use like ggplot
So yeah.
to have all of this one at the same. But one disadvantage of that, then we cannot have like seasonality. We cannot have seasonality. We cannot have random. We can compare one of them like terrain for both country, and then we have to go to random for another picture.
Country and so on. Okay.
This one is
Right.
showing like all observed trends, seasonal and random for each country and how actually they are. And so for Iran, at least there is something happened after 1965. It shows definitely that one. But for Pakistan, the variability is going high, but that problem fortunately hasn't happened. So
Right.
yeah, this is we will put all them like in the paper for all countries. Maybe we can have a look at Kenya as well.
Yes, please
So
do. You can
yes,
do it now if you like. It will take a minute, but
yeah,
it will be
yeah. So
nice.
let me change this one as a DF to work for everywhere, and DF, and then it will not take. Okay, yes, yes, and yes. Let me make it. And okay, let me go to Kenya and okay, and then yeah. So this is
Okay.
the results.
Interesting.
Yeah, for Kenya
Very
and
interesting. Very interesting. In Kenya, it is rising, and in
Rising,
Iran,
yeah.
it was falling. Yeah.
yeah, yeah, yeah.
This is
Even
a
the simple
significant
graph
change
shows
after
interesting things.
1960.
Yeah.
And also the I think at this time, like from maybe 50 to 90, like before 2000, the variation is high. We see the fluctuation is high here,
Yes.
but
Yeah.
seems this time is going with interesting trends or increasing trends,
Yes.
right?
Yeah.
So they are
So,
all
what do the experts say in the world about climate? The change, the effects of climate change. Do they say that those effects start from 1960 or 1950, or do they say that they are only happening now? Because in our graphs, we can see that the change is occurring at approximately 1960 for each of the three countries.
I was reading something. It was around 1960 or 1965. There
Yeah.
is a change in the world,
So
and
that's what we are seeing. That's what we're seeing here.
yeah,
Yeah.
I have seen in some in the paper that around 1965 or
Okay.
some things happened in the world. I think
Great.
because of the warming problem, global warming problem. It would be interesting to look at the temperature as well to see how
Yes.
the
Yes.
temperature will looks like.
Yeah. Yeah. And also, you will be able to, you and Haris, particularly, both of you, the machine learning people, you would be able to draw the bivariate graph also, meaning that we can see what's happening to rainfall and what's happening to temperature at the same time.
Yeah, we definitely
Okay.
we try to do that.
Mm.
So
So
that will be our next exercise.
I would like to suggest something. Dr. Raza, if you have time, and Haris, if you have time, The two of you can also get together, maybe just for the preparatory work before our next combined meeting.
Okay, inshallah.
Sure.
Thank you.
Sure.
So now you please do it for Nigeria also.
Okay.
We are still talking about rainfall now, not temperature yet.
Not yet.
This is rainfall, right? The Nigeria
Yeah.
rainfall.
Yeah, so we'll do another one for temperature.
Okay.
That we'll do later. Let's first finish the rainfall.
Yeah.
Oh, yeah, this one has very different patterns.
Mm.
This one, even in the beginning, there is more variability.
A lot of variability. Yeah.
Yeah.
And then
This
the
one,
variability
yeah,
And
has
then
less
around
variability.
less.
around 1960, it started falling. The trend fell, but then after 1980, it again started rising.
Mm.
Yeah, this is also interesting. So what's happening in this area and what's happening? So yeah, we have to discuss all of them. But if someone look at this figure, like this randomness here, if Dr. Harris, please correct me if I am wrong, then would suggest maybe go to some arch models as well, because for this one I see, you know, for Pakistan, for Iran, we had less, in fact, extreme point. But for Nigeria, we have, you know, so many extreme points, like raising or, you know, dramatically or falling dramatically in the random error, right?
Yeah. Yeah, we can check it.
Yeah, we may have to check it. So I haven't checked for the Karch models, but I'm guessing that the Karch model will have better performance, you know, to Nigeria compared to other models.
This random pattern is of error term that we are
This is, yes,
seeing in the
random
picture.
error. Yeah, this is for the error, random error.
I thought it was actually the decomposing our data into different parts, into trend and seasonal and random.
Yeah,
It may not
yes.
be of random.
So this is the random, this is seasonal, trend, and the observed. So the observed has been decomposed in 3 ways.
I
So I
think
mean,
Haris,
or
Raza,
error term.
I think Haris is wanting to ask, and I also want to know, what exactly do you mean by the word random?
okay, so we do know in regression analysis, right? What is the so okay, random term is something that we say that we cannot explain based on the variables. So we can explain some part of this model by trend. We can explain some of that observed by seasonal, and we can these parts, in fact, cannot be explained by seasonal and trends. They are random part. So
Okay.
the random part for this one is has very, you know, high extreme fluctuations. So
Yes.
we have, I think we definitely need to check the Karch model for Nigeria, and I think that one will have better. But let's go forward to just look at the simple, you know, simple model. So I had actually not only machine learning, I also used a very simple, you know, model of, you know, regression model based on times to see, for example, for Iran, as the time passed, what's going on? Is that increasing? Is rainfall is increasing as the time passing, or is decreasing?
Yeah, I have seen when you shows the model comparison, there is a model of regression, and it contains a higher error than as compared to other model. I thought the reason is that there is no trend in that model, the trend is I thought it is a random trend. It's not a some specific increasing or decreasing trend in our
Right.
data.
Yeah, but the thing is, Dr. Harris, is still if we look at just simple, linear regression model based on time and rainfall, we will see still by that one the slope is negative. So I wanted to.
Can you
Yeah,
do it? Yes.
yeah, sure. So let me just go here to Iran and maybe run the model for, yes, this is for Iran. So these things for, so let me look at the comparison model. So this is the performance that I don't want to discuss them now because they are quite simple, but let me, discuss get performance. This is a function of prediction values and the actual values, right? So my performance will be a function of predicted and actual values. So the residual mean B will be predicted minus the actual values.
Right.
Since I will use square, so or absolute, it will not it will be okay if we use value actual value minus the prediction. So both will be the same as long as I will use absolute or either absolute or the sum of scores. So we will use MAE, sum of absolute residuals divided by length of values. We will use RSS, sum of residual square, MSE, like RSS divided by, it's like mean square error. RMSE, root square of MSE. And at the end, we will in fact will have a data frame of this MAE, RSS, MSE, and RMSE. So this is
I just want to ask you about number 4. Number 3, RSS. RSS stands for what?
RSS is residual sum of square error.
Okay, because I was confusing that R with the root, root mean square and like that.
I see.
Okay.
So for that one, we put RMSE.
Right.
RMSE is root mean square error.
Right.
Yeah. So MAE is mean absolute error.
Right.
So these are the performance models. So why we use like the MAE or and so these two are like similar, but they are somehow different because some people use mean absolute error and somehow some of them use mean square error. So they are both
in the published papers, in other kinds of papers also we see that they are using so many different criteria, doing the same thing using different criteria.
I will suggest you some of the method, including mean absolute percentage error and symmetric mean absolute percentage error and so on.
Yeah, I will give you the code and maybe we can discuss as Dr. Salha told, maybe we can discuss later on. Right, so let me just, looking at the simple time series, to see what's the, what is the best time series for example, for Iran, right? So just simple linear regression analysis. So what we see here, so this is my time series model, and the slope is -0.1. It shows that it gradually, actually, the rainfall is decreasing as the time is going. So, which is in fact, which is a negative sign. So this is for 100 years. And if I change this for the last 20 years, then this -1% will increase to -2%. So which means that the trend is almost getting twice worse if we look at the last 20 years in Iran. So I haven't looked at this one for Pakistan and Nigeria. I just checked this one for Iran.
Dr. Raza, can you predict this model by using these values?
Yeah, I have the predictions, and I'll show you later on what's the prediction and everything. Okay, so by this, though this is not a proper model for Iran, definitely. I mean, this is not the ideal, this is not the ideal model, but I want to see what's the effect of the time. So my time, if
So,
is the time.
Dr. Raza, please teach me this thing. What is it that machine learning method does not, I mean, why did you have to do this? Could you not have obtained this information through the machine learning model?
Oh no, that's something that we can do that with machine learning, because machine learning does not show us if what is the sign of time, or like this. So is it
That we now
negative?
use to predict exactly the linear relation between the data somehow in a simple way, and we cannot relate time to our data set, or what going to be happen when time increases or decreases. So actually that can be captured more clearly by using a simple linear model.
Yeah.
Okay.
Yes, that's the reason that even it's not like, as I mentioned, ideal model, but it shows us how it works. Like if the time is passing, is it a good trend or bad trend? Which unfortunately, at least for Iran, it shows a bad trend. So we can look at this one for.
No, but why is it a bad trend? If it is a negative, it means the rain is decreasing. That's a bad trend?
Yeah, for Iran, it's a bad trend, because I maybe you have heard from the news nowadays in Iran there is a big problem in Iran. So many of the dam and
Oh,
water
I see.
resource,
I
water
see. I see.
resources, cut, and now this many cities has, they in fact uh, they cut the water in many times during the day, and beside that it is going to be a problem for the politicians, and in fact for the government, and many opposite raised, and they want to actually I think that there will be serious issues, like around this time. By this time, around 400 people injured, and around 10 people died because of the chaotic, and just because of the water. In south part of Iran,
Oh,
only 2 hours. Some people have water for only 2 hours, and
oh, oh,
other issue is that our electricity is strongly depends on the water. So
I
not
see.
only water is cutting, but also electricity is cutting, and like south part of Iran, southwest, the weather is so hot at the time of at the summertime,
Right.
and then people cannot leave, and they come at night and say against the government, and then some of them has been killed so far.
Oh, I'm sorry
So
to learn this. I did not know this.
yeah, unfortunately, that's a big issue. So that's why maybe for some other countries, it is good that, okay, if they had like too much rain, which is good sign, like Canada has too much rain, so still people are getting more happier here when they see more suns. But in
Right.
Iran, it is a disaster, in fact. So
Oh,
yeah, so we can look at this one. Let's see for the Pakistan, how it looks for the Pakistan. If you are okay, I can do for Pakistan to see
yes,
how the
please.
trend
Yes, yes,
for Pakistan, right?
yes.
So let me just uh, change this one. Okay, let me change
In
this
all
one.
developing countries, it is actually a problem if there is a very low rainfall. There may be a different issues, as Dr. Raza said, issues of drought and many other issues related to industry and other areas or other sectors. So,
Right.
especially in Pakistan, we are actually running our economy on agriculture, and agriculture land definitely needs water.
Right. True.
Yeah, it's unfortunately it's becoming a big issue. Oh, interesting. For Pakistan, uh, you know, it is increasing. So
But when
generally,
you get your regression coefficient such a small number, uh, you still say it is increasing. It is very, very close to zero. The negative one was also close to zero, and this one is also very close to zero.
you know, this is 2%. It is, although it is close to zero, but it is time, you know, and this is monthly. So our time was monthly time, right?
Right, right.
So, the trend is good. At least it shows that the trend is good. But though this model is not the ideal model, so we can check for other countries. So if we look at the Pakistan, I think that the trend. So let me go to the composite function for Pakistan to see how that's one in long run. So maybe we can see again. So how the trends. So I wonder what is your actually idea from this, is that
Slightly
increasing
increasing
or
trend.
decreasing?
Yes.
Seems at least, you know, based on this time, it seems that is in increasing, right? So
Yes.
Slightly
compared
increasing trend.
to
Slight.
yeah, very slight increasing. Yeah.
Yeah, definitely.
Okay, so these are some of, you know, though they are basic, but they shows us something. And we, in fact, you know, we don't know what happened. When I was kids, let me explain you in Iran. When I was kids, we see all of the places were covered by the river. We had very nice river around. Almost every village has its own river, but now all of them gone. There is no more river, even the other water, you know, the underground water fell down significantly. Okay, so that's one thing, one part that we, in fact, we need to have like this the composite function, and maybe later on we could work together to make plot to compare all country at the same time. If we can do that, that one will be okay. So the model that we, in fact, we worked last time was, as I mentioned, the neural network model. So which in fact doesn't need to be the linearity and also constant variance. And the model is quite simple. Just we need to run the package, forecast package, and NN net or this function, and it will shows us the how which model, which ANN model will work, and which lags or which the how many, in fact, time period we need to forecast our model. And we just simply need to, if we want to make prediction, we can use this spread function to make prediction. And we just need to say how many days or year or months ahead we need to have. So okay, we can have
So Dr. Raza, I have two questions here.
Sure.
Number one, if you could one more time tell me and tell all of us the relationship between the machine learning and the neural networks. Is machine learning a part of neural networks or vice versa?
Okay,
And
thank you very much. Yeah,
and
so
number two, the other question is, previously you used such a simple linear regression model for prediction. Now you're going to use neural networks for prediction.
yeah, so let me explain you. So generally, what is machine learning? Machine learning is it is in fact a concept, like what we say as statistics, right? So statistics is a major, and so it will have some, you know, categories like biostatistics or pure statistics or applied statistics. So machine learning is in fact a broad category. So that will have this, you know, sub algorithms. So several algorithms actually will have been used in machine learning. First one, some people even say, okay, logistic regression or linear regression is kind of machine learning. So though we may not agree with them, but artificial neural network is one of the machine learning algorithm. Okay. So machine learning is like an umbrella that cover a lot of algorithms. So of them, artificial neural network is one algorithm. Support vector machine is another algorithm. For example, KNN is another algorithm. And so far, I think based on my last experience, there was around 30 algorithms developed by and called machine learning algorithms. So now the
Thank
thing
you.
is which one is better. So one big difference between us as statistician and machine learning is that in statistics, in theory, we prove that which method is better, right? So in terms of MSE, we can calculate the MSEs
Right.
and we can do simulation, at least if we can't capture the MSEs, and then we will say which method is better. But
Right.
since, and in fact, we need, if we want to calculate MSE, if we want to calculate the bias, what we need to have, the distribution of the data, at least. But here, and if in fact also confidence interval, if we want to draw confidence interval, we need to have distribution of the data. So maybe for MSE or bias, we don't need the distribution. But for MLE, if we want to find MLE, we need to find distribution, and if we need to have distribution, and if we have the distribution of X, then we can calculate and say which model is better and which estimates is better.
Right.
In machine learning, we don't have that distribution. So we don't have that distribution, or at least the distribution does we cannot fit any specific distributions because of so many reasons. For example, outliers, or maybe nonlinearity, or maybe other issues, right?
Right.
So as long as we can't fit distribution, then industry asks, okay, do something for us. For example, will the product will be sold out or not, or how much the house price, etc. Right? So in this case, we need to do something. We need to actually, as a scientist, to give them an answer. So then people start to propose different kinds of algorithms. Each one will work in a specific way, but somehow they are working independently. For example, the way that artificial neural network works is different than the way that support vector machine works, which is different than the way that KNN works. So all of them have better accuracy in different scenarios. And in fact,
Okay.
I had a PhD student in Iran, and I asked him we should propose different scenarios, simulate the data in different scenarios, and then look at generally see which algorithms work where better. You know what I mean? So
So
that was,
are you saying that it is more like a trial and error method?
yeah, by simulation. So we wanted to do the job by simulation because we cannot do the job by theory, unfortunately.
Okay.
But in practical situation, how we can say which method is better, we have to do train and test. We have to train
Right.
and we have to validate our model to see which one has better performance. But there
Right.
is an issue here. If the data change next time, then we don't know. Still, we have to update our model. Maybe another model will work better. You know what I mean? So, but in the statistics, when we say something is blue, based linear unbiased predictor, or bloop, in fact,
Yes.
here you may know a guy, professor, I mean Balakrishnan, N. Balakrishnan, working
Yes.
in McMaster University. He was my
Yeah.
supervisor for
Right.
part of my PhD thesis. So he was teaching us bloop, best linear unbiased predictor. And he was
Estimator.
showing that
Yeah.
some estimates, some predictors are in fact bloop. And then there
Yes.
is no more, no longer better estimates that will be than this one, because we have
Yes.
shown that already. But here, even if the data change, we know the type of the estimates. We know the bloop. But here in machine learning, if the data change, then maybe, if the pattern change, then we have to update our model. So,
Right.
I mean, machine learning is a broad category. is a subcategory of artificial intelligence. So then, so artificial intelligence is a very broad category.
Right.
Within that self, we have machine learning, and after
Right.
that, in second generation will be deep learning. So all of them,
Right.
like, in fact, they are including some algorithms. And the best book I can tell you is Rob Tibshiriani,
Okay.
Hasti and Tibshiriani, Element of Statistical Learning. So he, in fact, he told them like statistical learning, not machine learning. So, you know, Rob Tibshiriani, so if we go through, like, just Google it, like he's one of the best and famous professor at Stanford University. Let me
Okay.
show his Google Scholar, Robert Tibshiriani. Yeah, this is Rob Tibshiriani, professor at
Okay.
Stanford University, and we can see his paper and citations. Uh, uh,
There's a lot of screen delay, but now finally I got to see the picture. Okay.
yeah. So one very interesting paper of Rob Tibshiriani is this one, regression, shrinkage, and selection via lasso, or we say that lasso estimates. So this is,
Okay.
and get 40,000, around for 41,000 citations since
Oh, okay.
1996. So
Great.
this is one of the, in fact, the good papers, in fact, best papers by Rob Tibshiriani. And I think another one is, yeah, this is nice book, Introduction to Bootstrap, but I wanted to show you the book, Element of Statistical Learning. Yes, this book, An Introduction to Statistical Learning. This book is almost
Okay.
freely available everywhere. So he called them as a statistical learning for several reasons. One is saying that they are non-parametric methods. So, and I
Right.
mentioned you, there is a like issue between the statisticians and engineers in terms of, okay, is that machine learning or a statistical learning? So they believe this is a statistical learning, not machine
Okay.
learning. And they explain why in the book. And they have explained all of these machine learning or statistical learning algorithms by R codes. So they give like R codes, free examples and explanations. So there is two books. One is, in fact, one book is called Elementary of Statistical Learning, so which doesn't go too much deep on the theory, but this one, An Introduction to Statistical Learning, this is deeply go to theory and shows the theory of those methods, right? So
Okay. Thank you very much.
I really recommend these two books for everyone who want to get intermediate or even advanced in machine learning or statistical learning. So yeah, Rob Tibshiriani is a very famous, and now he is professor of biomedical data science and statistics at Stanford University. He has also like several workshops. If we Google on YouTube, we will see there are so many nice workshops given by himself, Rob Tibshiriani, and they are so interesting.
I
Okay,
see.
so
Thank you very much for all this information.
no problem. So yeah, so artificial neural network has been so used uh, in medical science for prediction of cancer, and other disease. I have used them like, and the paper from us has been also published, and I can show you here. So I remember last time when you were introducing, you said that, okay, we submit some papers, but now the paper has been published. They are freely available. So uh,
Okay.
ANN, in fact, so it's like our brain. So use from different experience and want to make prediction for the next. So here, what this neural network use this one see see like rainfall for this year, how much affected by the or in how many days or lags needed to predict that the rainfall for the future. So lag or previous stage or previous rainfall is in fact is going to be considered as a predictor for the time series. So we can do forecast function. So as long as if we fit the model, we can use the forecast function to see how it has. Oh, sorry. Let me pull out the forecast. So this is the forecast of the next 3 years based on the artificial neural network, and we see the trend is low. The prediction is low. So here there are some parameters showing that. So this 12 showing that this is a monthly time series. This 28 means that our prediction model, our neural network prediction model will depend on the last 28 months. So the last 28 months is important for the prediction. So this one used.
Where is the number 28? I don't see it.
Oh, do you see at the top of this one, this figure, forecast from NNR?
Okay.
Yeah,
Okay.
28, 1, and
Yes.
14.
Yes.
Okay.
So what was it? 28 was the.
Yes, 28 shows that our prediction for today, or maybe for this month, will depend on the last 28 months.
Okay. Right.
Right.
And
so
one.
Yeah. So 1 shows that we have used only one hidden layer.
Okay.
This is 14. I forget what it means, because last session I registered, I wrote somewhere, but now I forget.
Yes, I think so.
I will tell you what does it mean. I forgot this. So this is the optimal. In fact, this is the optimal artificial neural networks.
Right.
And this is the forecast for the next 3 years. So if somebody want to use artificial neural network to forecast, he will see what is the value for the next 3 years.
So will it always give forecast for only 3 years?
No, it depends on how many H we put here. So I put H equal to 36, we can put H equal to maybe 22, etc. So one disadvantage here is that, so in time series, we do have something called confidence interval. Here, artificial neural network will not provide us confidence interval. We have to do something called bootstrap simulation to make confidence interval, which in fact, maybe if I am now thinking of to do that or not in the paper, because we need to have confidence interval. So these are just point prediction. So we know the issue of point prediction. So the point prediction will not be so much good without confidence interval, right?
Yes.
So
I
in
agree.
fact, we don't know the error of the point prediction. Nice things about confidence interval showing the error of the point prediction, but we don't see here. So we need to do some bootstrap, in fact, studies to show to see the confidence interval for this one. I saw a paper.
The code that would be written for the bootstrap, is that I mean, you have to write it from scratch, or some code is already available?
I have to check it. I didn't see for this package to find the confidence interval. This package doesn't have the confidence interval, so I have to check it, or I have to write myself.
Which package is this? I mean,
this is just a forecast package. So they in fact they add this function to forecast package to do neural network time series as well. So this is in forecast package. I have the packages here. So forecast, OpenAir, Hydro, and XTS. So this the last 3. I mean, so this is just replication. for taking the average of 12 months and so on. So
Okay.
and so we can do also, we can check prediction, just prediction, PRED function for the next 24 months or 2 years, and this shows us for the next, okay, January 2021 will be 38 millimeters, February 28, March in Iran, as I mentioned, always in March we have the highest, generally the highest value of rainfall, and so on. So this is the simple prediction, very
So
simple.
now you can compare it with the actual values because it's already happened.
Actually, I haven't checked, what happened for the January 21. So maybe if you send the link, we can look at if they have registered so far the January. I'm not sure if they have done
Right.
for January 2021.
Right.
So for prediction, I use train test to use, to use the data, our data. So maybe Dr. Avi, do you have the link for that to check what is the value for January 2021 for Iran?
I have just now done the Google. If you want, I can share my screen.
Sure, go ahead, please. Let's have a
I
look.
just typed it on the Google, but yeah, okay, I can do it. I think I can do it.
Thank you
So
very much.
this is what I wrote, rainfall in Iran in January 2021. So first it says Tehran only, but this one says Iran.
Okay,
So
let's look.
Let's see.
Thank you.
Okay. I think it's not giving, well, it says on the top, but
Yeah, it's strange why they didn't put.
sorry, what?
I mean, it's strange why we don't have the rainfall for January so far, at least.
That's what it said on the top. I don't know why.
Yeah.
Please write average rainfall in Iran in January 2021.
Average, okay.
Rainfall.
No, but you want average or, I mean, it's 2021. So what do you mean by average?
It means about all country, whole country.
Yeah, but
Rainfall measurement were taken at different point in country at different place, and finally that can be averaged into make a single value.
Dr. Harris, maybe we have to, Dr. Salah, we have to check the same database that we got, because maybe they are different in measurement.
So do you,
Sure.
if you have the link, you can do that.
Dr. Rasa, we can do that by splitting our data into test and train part.
Yeah,
and we
I have done this. Just we wanted to, for the previous, we have done this, but for now, we wanted to see how much will be, the
in reality, how much happened and how
just
close
making,
is, yeah.
I think it was global. Sorry for my fault. I should register somewhere that one, that link. Dr. Avi, I think you had the link, but let me see what was the link.
Dr. Avi, can you send that link again?
The link of the data?
Yeah.
Yes.
Okay, okay. Give me 1 minute.
Oh, World Bank data, maybe.
I think he's just going to give it.
Okay.
Yes, Dr. Ave, did you find it?
I'll send it to the. I'll
You
send
can
it to
put
the.
it, you
Yeah.
can put it in the chat also.
Okay. Okay.
Yes, Dr. Ave, have you found it yet or not?
But I will find it soon. I've not found it. Sorry. I'll find it soon.
Okay, okay. In the
Save this somewhere.
meanwhile,
Save this somewhere.
okay, please do continue searching. And Dr. Raza, if you want to do something else in the meantime, you can do it.
Yeah, so this is what I was telling is that so this artificial neural network is one stage more than ARIMA models because we don't need to check the linearity or assumption of the ARIMA models.
Right.
So which was in fact we think it is good. So but if we want to have paper, definitely we need to add some other models and compare them. So I have like other models. So let me tell you which models I have added. So maybe
So please, you need to share the screen again.
Sure. Let me do that. We have 3 minutes left, right?
Okay, Dr. Ave has given the link. Now you can copy that link, please.
Okay, okay.
Yes, please save it. Save it also.
Thank you.
Yeah.
It will be like a penalty for me if you don't give me the link later on. I should have saved that one. Thank you.
You're welcome.
Thank you very much. So let's look at Iran. So do you see my screen or not? I'm just checking for Iran to see if.
But we don't see your screen, Dr. Raza.
Dr. Salahat, they do have by 20. They don't have 2021 yet.
Oh, okay. But we are not able to see your screen.
Okay, okay.
Yes,
Let me.
We can't see your screen.
Oh, sorry. Yeah, do you see now?
Yes, now it's coming. Yeah.
Yeah, so I put like Iran. So, and the time to download, this is until, you know.
Yes, that's what they have.
Yeah, it's not available yet.
Oh, okay.
Yeah, so that.
But I have checked, it's not available there. So we can check it for another country. The data for Pakistan is available for January 2021.
Okay, let's check it.
You don't want to see it now.
Let's make it for Pakistan.
Go
That's
on
okay.
again. You take
All right, please, let's do it.
Yeah, let me do for Pakistan. So let me do just, I'll put just the name like simply TS. Let's run the model and see the prediction. It may take a few more seconds.
Is it now for Pakistan?
Yeah, it's now for Pakistan. I used the yeah, Pakistan. Yeah.
All right.
Okay, it's done. Let's do the prediction for, and so for January, it shows 24.65.
Okay.
February 30.46. Do you have the
Okay.
data, Dr. Harris, to check this one?
Sure, I'm searching it and
Okay.
sure.
Are you searching on that same database or somewhere else?
Somewhere else, you may just please simply average rainfall in January 2021 in Pakistan. The values will be given by Pakistan Meteorology Department.
Okay, let's see how this. So, Dr. Salah, as you mentioned, in July, it was the highest rainfall, 52 millimeters.
Oh, yeah.
And August decreasing, 46, September decreasing. Yeah, at least it shows the pattern. It is smart that we'll find out that in July.
July and August, as I said, are the monsoon season months.
Yeah.
And that's every year, these are the 2 months when we have more rain.
I see. Yeah.
Yes. And you can see it is much higher than
Yeah,
the
exactly.
other. Yeah.
Significantly higher. Yeah.
Yes. Haris, have you found the real data?
Yeah, just a minute, please.
So November is quite low. So the minimum rainfall was in November. Will fall. In fact, November has not been happening yet.
Yeah,
so
yeah, that's very low.
almost. Yeah, very. 1.5.
Yeah, sometimes we have this case that there's no rain for a long time,
Right.
But I can't.
So there
I
is
cannot.
7.8 mm in January 2001 in Pakistan.
How much? 27.
Every 7.8 mm.
But this is 24. That's very different.
Yeah, it's different.
Haris, can you share your screen? Where are you looking?
I have opened it on my laptop. So can you please, if you share the screen, I can tell you how can you check it.
Dr. Raza, you can do it.
Dr. Raza, can you please
just
open
go to the Google.
Okay.
Okay, please write average rainfall in Pakistan. Rainfall in Pakistan in January 2021.
The spelling of Pakistan has to be corrected.
So that is 7.8 mm. So this is the official value that was given by Pakistan Meteorological Department.
That's too much different than what we.
Can we check the?
No, that's also.
Can we check our data set?
18.9.
Data result.
No. If you complete.
Yeah, the normal rain is 18.9. What is your prediction, Dr. Raza? Again, let us see the predicted value.
24.
Okay. And let's please type for February. Could you type?
Dr. Raza, can we check for December 2020 and verify that value from our data set, please?
Sorry, can you ask again?
Yeah, can we check the value of December 2020 and verify that data set, that value from our data sets?
Oh, okay. So we want to make sure. Okay, let me check
Yeah,
it
please.
for Pakistan rainfall. So which 2020?
December, so that is 15.7. So can you check it on Google?
Okay.
15.7. Okay. So
December
now on the
2020.
Google also you write December 2020.
So I thought so. There is a
Yeah, it's
difference.
different. See?
Yeah,
Oh, it's
yeah.
very
It's
different.
something.
last time
Wow.
I have talked to you about the data from World Bank, and I was telling you that I have seen many papers and no one has used this data set from the World Bank site. And
Okay.
still I am confused about the authenticity of that data. As I have told you, it is from 1901 of all countries. So
Yeah.
I thought we have to check the authenticity of this data set before
So you
going
mean
to
that
publish.
now we can, I mean, for any country, it can be not what it, I mean,
Yeah,
we
I
can't trust
thought.
it, right?
Yeah, I
We
thought.
cannot trust the data then. Wow. Dr. Ave, can you see what happened? I think Dr. Ave,
That
yeah?
publication
Yes.
shows that the value of December will be 15.2, and actually Pakistan Meteorological Department, that is the official website of
Yes,
Pakistan, and this is
yes,
8.2.
8.2
So
only. So it's very different.
yeah, that is.
But it's very strange because obviously people should be using the World Bank. I mean, what's the World
Yeah.
Bank doing if they are doing it so much incorrect? I mean, what is this?
Yeah, I think we can trust the World Bank better than some of these Google data.
No, no, no.
Oh,
Haris
not a
is
Google
telling
data.
you
It
that
is
this
a
is the
Pakistan Meteorological Department
official
data.
website of the Pakistan
you-
Meteorological Department.
Can
Oh,
you check
right.
the link www.pmd.gov.pk?
but
That is the official data from
but they are
Government of
also
Pakistan.
Yes.
they are also saying 13.3 against is normal.
The normal one is 13.3. Okay. So what did we have on in the data? 15 point something?
15
Yeah,
point
it was
something.
15. Yeah,
No, but Jawad, even then, even if it's below normal or whatever, the actual figure is 8.3. So it should have been on the World Bank one also. It should have said 8.3 or 2,
yeah,
whatever it is. Yeah.
it's a
Yes,
little bit
yes.
We
now.
can test it if that is somehow close to 8.2, but it is very far away.
Hey,
That is
Allah.
15 point something.
Yeah.
So what do we do now?
I was still confused in all this work that we have to particularly discuss on the data set because when we touch some applied journal of some meteorological department that can specifically ask about the authenticity of data set and the where we have taken that data from and so on. So we have to.
Yeah,
This is
so
very interesting.
yeah, now
Even then, when I wrote the paper, they told me to mention the longitude and latitude that from where coordinate the data is collected. So
I see. In
yeah,
your paper for your thesis, your PhD
yeah,
thesis.
yeah.
So
so
how did you do it?
I have now for that situation, I have taken the data from meteorological department of Lahore, and for some particular coordinates instead of using the data of World Bank. So the values
now
of
I
World
think
Bank was far away from
now
actual
we
one.
need a few days to think about it, what we are going to do.
Actually, the data on World Bank side is from 1901. That is also alarming situation. As I have told you, the Independence Day of Pakistan is 1945. So it was not elaborately captured. The data was not elaborately captured before 1945. As we didn't have
1947, Haris, not 1945.
1947. We didn't have better tools before that years. So
So, well, in that case, we have to see when Iran was an independent country, when Pakistan was, and when
we have
Kenya,
to
and when Nigeria.
check, yes,
And then we have to
we
take
have
that date, which is the nearest
some
to the,
overlapping date that can be used for all countries jointly.
for all the countries.
Okay.
Yeah. So we have to mention our data, these all the things in our data methodology instead of just using.
I think that Mr. Harris, what he's saying is right, because you see, prior to the independence of Pakistan, it was India. The whole region was India. So I think he's right that all those years from 1901 to 1946, there might have been some kind of an estimate of, of these parts which are in Pakistan now. Is that what you're saying, Haris? That
Yeah, that is.
those numbers which are written there, they even might be in a kind of an estimate of what occurred in those parts of the world which are now Pakistan.
Yeah, that is. So if we are doing some methodological paper, then that is enough. We are comparing our methodology and presenting some new methodology. But when we are actually dealing with data sets, we have to talk about the data, about the authenticity of the data.
About the authenticity and correctness of the data. Yes.
Yeah.
So sorry, one thing, maybe Dr. Avi, you have idea. So if somebody has published at least one paper from the World Bank data, then we have to check how they published and where they published. Maybe there is an explanation, because the too much gap is something, it is something very strange to me. It shouldn't be that much. Maybe the way that they capture the data is different, right?
Dr. Raza, sorry to
Yes.
interrupt. I have checked
Yes.
several papers on climate change. None of them has been using the data of World Bank. I am searching it from last half hour and before
Oh,
that
sorry,
time.
sorry, everybody. My little daughter is crying, just asking me, so I have to go.
It's almost time. It's almost time. Thank you very, very much, Dr. Raza, for all the effort, and thank you, Haris, for all the good input. So we'll not let you. She's crying, so you better go. So we are going to say goodbye now. Okay. Thank you very much.
Thank you.
Bye-bye. Thank you. Bye-bye.
Thank you.
Bye.
Bye, everyone.
Bye. Thank you.
Bye.